Thank you everyone for taking time out of your morning to join us today. My name is Jeff Cole, and I'm a BMC software consultant specializing in the AMI Ops products. And today what we're going to do is we're going to talk about managing ZOS objects with AMI Ops automation. A couple administrative things is we've scheduled this session for an hour, but we're really targeting it to be 30 to 45 minutes, so we won't take the full hour. Second item is we will have everyone muted for the duration of the session. We don't want to reveal anyone's identity. We have many customers on the call, and it'll allow us to stay on topic. Alternatively, if you have questions, I encourage you to either send it to me via email. You can see my email address on the slide, or you can type it into the chat. And we'll follow up with you within a day, tomorrow at the latest, and get you the answers to your questions. Okay? So let's go ahead and get started. So what is BMC AMI Ops automation? Well, BMC AMI Ops automation is a key tenet of BMC's Automated Digital Enterprise, or ADE vision. AMI Ops automation provides important technology, right, to develop meaningful automation everywhere, including the ZOS ecosystem. So BMC has a larger initiative, and the AMI Ops automation solution plays a key role in it. Now, BMC AMI Ops automation was previously known as Auto Operator. As you may know, last month we did a major rebranding of all the MainView solutions. When we talk about BMC AMI Ops automation, there are really two key capabilities it provides. We have event management, which is setting actions based on the occurrence of events such as messages being issued, commands being issued, timer pops, variables being updated, and many more things, such as CICS, TDQ messages, so on and so forth. And the second thing that BMC AMI Ops automation does is it provides you with state management. And there are two features that come with Auto Operator to do that. One is Continuous State Manager, which is really focused on started tasks, and it's an older technology. And then we have Total Object Manager, or TOM, which manages diverse objects. So Total Object Manager is what we're going to talk about in today's session. So what is BMC AMI Ops automation, TOM? Well, Total Object Manager provides an infrastructure to manage diverse objects in your ZOS ecosystem. All right, TOM can manage either a single system, or it can manage objects across a sysplex or a subset of the sysplex. TOM also has robust calendaring capabilities to define object schedules. You can also define schedule overrides for specific objects for certain times. And TOM offers many, many automation points within your object management functions. So TOM doesn't limit you to just issuing a start and a stop command. There are many other things we can do in addition to that. So AMI Ops automation TOM was formerly known as Auto Operator TOM, and it manages a variety of different object types. Of course, we manage started tasks, which I think all of you should know what those are. We also manage WLM resources, USS processes, and we can manage stateless objects such as VTAM resources. We can issue USS scripts to do setups. We can monitor initiators and anything else that we can query with a command to interpret what its state currently is. So what does BMC AMI Ops automation do? Well, it does two things. It primarily manages availability of resources in the system, and it helps to manage your IPLs. So there are two different things he does. He provides us with operational capabilities, and that is start and stop objects, bounce objects, recover objects, move objects. There are many, many more different functions, but those are representative of what we can do. And then administratively, we can define the objects, their schedules, their dependencies, and we can also define sets of objects. So what are objects? Well, TOM stores them in what we call definition bases, and they come in four flavors. We have normal objects, which are your typical started tasks. They come up, they go down, everything you typically expect from an object. Then we have transient objects, which are objects that come up, they do something, then they go away. So those types of objects, instead of showing them as active, we'd show them as complete. Then there are two special type of objects, which I'll talk about in a little more detail on the next slide. So we have this notion of model objects, which are special objects that just contain properties. They're not managed by Tom. Instead, what they're done is they're referenced by other objects that pull in their attributes. So for instance, you may build a CICS model that has like the DFH 1517 for initialization and similarly for start and stop commands. You could put those in a model, and then when you build your CICS objects, you could reference those models without having to define all those attributes. Furthermore, if you come back at a later date and you update the model, you don't have to update the objects that reference those models because they will be updated automatically. Now, another type of object we have is what we call a layer object. And layer objects are used to create identical objects across systems. So it's most useful when you have an LPAR that's been cloned and it's very similar to the LPAR where you're running Tom. You could pick it up and move that entire structure over to the other LPAR. It doesn't work well when you have things that are named differently, so it's of limited use. But if you're running in a large environment like that, this could be a lifesaver. So just be aware that capability is there. So the next thing I would talk about are sets. And sets are just logical grouping of objects so that Tom can act on them as a single entity. They can be related, so you could have a group of CICS regions, such as something called CICS prod, or they can be unrelated. Maybe you have a DB2 that you want to build in a set with CICS or IMS regions. Sets can also contain other sets, and you can nest them up to 16 deep, which is well beyond the norm of reasonable, but you can create sets of sets. Tom supports two types of relationships between objects. We have the idea of parent-child relationships, which makes sense to most of us, and then we have the idea of client-server connections. Now, the parent-child connections we can define as weak or strong dependencies, which will determine if the child comes down if the parent stops, right, or if you want the child to continue to run. And the client-server is managed via commands to connect and disconnect. Tom also has this idea of calendar dependencies, and the calendar dependencies are stored in calendar bases. And what they do is determine when Tom should make an object active or inactive. Now, if you don't define the schedule for an object, Tom assumes that it should be active all the time if the dependencies and other criteria are met. But in terms of scheduling and calendars, Tom will assume it's always needs to be active. Additionally, we can create calendar dependencies for commands. So you can say, well, only on certain days do I want to run these extra execs or commands against the object. And it's pretty easy to accommodate that. Also, you can set up default schedules for your objects, and then you can set up calendar overrides for specific objects and times. So let's mention what a Tomplex is. And a Tomplex is all of the Tom started tasks running within a sysplex, or a subset of systems in a sysplex, if that's the way you have things configured in your environment. We call those a Tomplex. And all the Toms in the Tomplex cell share their definition bases, and they're interconnected. And by interconnected, I mean that you have the ability to move objects between those systems in the Tomplex, or you can have cross-system dependencies. So they are integrated when they're shared in a Tomplex. The definition bases and the calendar bases for Tom are stored in a registry, which contains all the information to maintain it across system restarts. Last thing to point out is Tom started tasks communicate via XCF, so high-speed connections, and again, only within the sysplex. Tom has two user interfaces. He has a full-function 3270 interface, which you can access through ISPF or VTAM, and he also has a full-function browser interface. For the browser interface, the server runs as a ZOS started task, so there's no distributed server required, and you can graphically display and control your object states, definitions, relationships. You can do everything in the GUI that you can do in the 3270 and a little bit more. So here's an example of the TOM 3270 object view. This is the primary display of the objects that you will see. On the left, you'll see the name of the objects. In this case, BMCA is the name of our LPAR. We like to put that in there because each system will be unique this way, because you may have similar objects on your LPAR such as LLA, and you need to have them be distinct within the definition base. So the recommendation is to prefix it with the system ID. So that's why we have those there. Then we have a field called evaluation status. That's the status that Tom says the object should be in based on his evaluation of calendars and dependencies. The last status field indicates the current status of the object in the system. If it's inactive, it's not running. If it's active, it is running. If it's complete, then he ran and did his thing. Then we go over to current system status. This is the current status in Tom. So you may see it active, you may see it stopped, blocked, locked, but you may also see an error status here, such as recinit term, something like that, and then you could troubleshoot why it would be in that status. Typically, you would come over here to the right where he has children, schedules, and dependencies. You can put your cursor on those values and press enter, and it'll take you to the display of those subsequent objects or schedules, and you can begin your evaluation of why that object may not be running. But this is a handy display. It's the primary display you'll come into. And now I want to take you and show you how the objects look for definition. So let's assume that I took one of these objects and I put an E next to it for edit. And I'm going to come up with a display like this. So here we see the first display in the object definition dialog. And up here we will put a description of what it is. We'll give it a short name, which is typically the same as the started task name. If we come down a little bit here, we tell Tom what valid systems for this object. So you can give him one or more systems in case it's an object like that you want to move between LPARs. You would need to find all the valid LPARs in the valid systems list. And then you can set an affinity to those LPARs so that he only runs on the first LPAR unless you specifically move him to other LPARs. Or you could have him fail over to other LPARs if that makes more sense for your environment. Okay. Here we have the schedules and the calendar override specified. If it's transient object, we select this field here. If we want to use a model, we can specify it in the model from field. If we put a question mark there, Tom will return us a list of models that we can select from. We can also define this as a model by selecting this as the model yes, and then those attributes can be inherited in other objects. And then there are more things here. Down at the bottom, there's a field called IPL level. And what that does is it allows us to do our startups and shutdowns in segments. So for instance, you may have an IPL level of mate to bring up TSO and VTAM and JES. And then you may have an IPL level of online to bring up DB2 and CICS. And then maybe you have an IPL level of all to bring up everything else. So you can set a parm in the Tom started task when he starts up to recognize those IPL levels, and then he will stop at those segments, and you'll have to issue a command to go on to the next one. And that can be very useful in a DR situation, because all you have to do is tweak a parm on the Tom started task or in the start command, and then he'll recognize those IPL levels so you can do what you need to do to bring the system up successfully. So if we go to the next screen, here we specify some overall information about the started task. And in this screen is where we specify what the start validations and stop validations are. So this is really a pretty easy screen. I'm just going to select start validations to show you what it looks like. And this is what you would see. So here we have a message ID, the started task, the message ID is coming from. And then we could optionally put a mask for the message to query some text within it. Okay. The next screen in the object definition dialog is for the start information. So here we have a lot of different fields. The things of import are here in the middle, and these are where you issue your actual commands to start the object. So by default, you'll have a start command of space SDC name, which is a variable for the SDC name field. We can also add additional start commands. We can also have pre-start commands, post-start commands. We can have start retry commands. So there's a lot of flexibility there in what you want to do with your startups. We can also use command labels on the commands, so you can start them dynamically, meaning you could use certain commands in some instances and different commands in other instances. Okay. These commands can also be composed of USS processes or execs. They don't have to be ZOS commands. Now, down here, let's see, verify start. What this will do is this will issue a WTOR to the console saying, do you really want to start this object? So that's built in for all the objects. You can do it for stops as well as starts. Down here at the bottom where it says active check program, this is what we would use to evaluate the status of a stateless object. So for instance, if we were looking at the status of an initiator, we could have an active check program that did a DI and interrogated the response to determine that initiator was in a good state. We could do that with any program, so it doesn't have to be initiators, anything that we can query. Okay? Similar to the start command information is the stop command information. Again, we can specify a bunch of different commands and execs to control our operation. We can use command labels if we want to do them dynamically. Down here at the bottom are a couple fields that say how you want to handle failures. So if the object fails and you want to move it to a different LPAR, you would select that, say yes, and then if he comes down, he'll move them, and then move if system failure. If you select no there, then he will not try to bring that object up on a different system in his valid systems list. Now keep in mind, he will not move it unless he has another system defined to move that object to. And in most cases, you probably will only have one system definition for your objects. So on the Dependencies panel is where we define our relationships between objects. And here I'm going to show you what the dependency field looks like. So I would select that or do an E for edit. And Tom's going to pop up a display like this where I can see all the dependent objects. Now, if I put a question mark in that field, Tom would have brought up all the objects and I could select it from the list what objects I want to be dependent upon. Another thing we can do here, I'm going to back up a screen, is we can set up complex dependencies using dependency formulas. So an example of this may be you have a DB2 that needs to be up when one of three CICS regions are active. So you could define a dependency in DB2 that says if CICS1 is active or CICS2 or CICS3, then consider the dependency satisfied and bring up DB2. So that's an example of what you could do. It's pretty robust. You can do a lot of things. If you want to get really fancy and crazy with the cheese whiz, you can use these user properties and attributes to do some fairly sophisticated things within Tom. Those are usually used on a case-by-case basis, so not something we typically push customers towards. Okay, I mentioned that Tom also has a full function graphical interface, and I want to show you a couple displays that give you an example of how that looks. So here we're looking at a display of all our objects, and I right click on the object, I select line action, and here are the first set of actions available to you. You'll notice there's another entry for line actions for subsequent commands. There are more of them, but in this case we just want to edit the object definition, which is this first field, and I'll pull that up so you can see how that looks. And you can see it's very similar to what we saw in the 3270. It's just formatted differently, right? You've got little boxes instead of fields to work with. So very similar, full function. You can do your object definitions either place, whatever you're more comfortable with. Now, dependency chart is something really nice that Tom puts together. When you build your dependencies out and you've said, okay, these starter tasks are all dependent, I've got my tree defined, Tom will interpret that information and build a dependency chart like this. And this actually shows the status of the objects in real time, and you can take actions against them. So you can start and stop objects from here, you can bounce them, you can change your dependencies, you can add objects. So this display here, this dependency chart, is full function. You can do pretty much everything you need to do here. It's a pretty nice capability, particularly useful when you're doing IPLs, so you can see where things might have gotten hung up. So what are the benefits of Tom? Well, I think I've covered a few of them. I just want to review them fairly quickly. Tom is sysplex aware, right? He can recover or otherwise move objects to alternate systems within the Tomplex. Object dependencies can span systems, so you can have dependencies on system A that rely on system B objects. Communication is via XEF, so it's very fast, very efficient. Tom also offers extensive calendar capabilities, so he controls when an object is active. You can also control when start and stop commands are issued, either pre or post start or stop, and then the start and stop retry commands. We also allow you to specify schedule overrides to the calendar that can apply to certain tasks at certain times. When we talk about objects, some of the values are that objects are shared among Tomplex members for interoperability, so we can move things around. We can rely on each other across system. Objects can be locked until the next IPL or blocked across IPLs. So Tom can stop objects, but he also has this notion of locking objects, which says I want to keep this object down until somebody explicitly starts it back up. And then there is the notion of blocked, which says keep it down, even if I IPL, don't start it up until somebody explicitly unblocks it. So those can be handy functions. We can use variables throughout the Tom object definition panels. Objects can inherit attributes from models, which eases the administration, particularly for CICS regions. We can group our objects into sets, which makes our environment much more manageable. And we have the ability to issue WTORs from the panel for object start and stop, which can be nice for specific objects that you really need to stay in control of. Tom gives you a lot of flexibility in using RexExecs. We can schedule multiple execs for pre-start and post-stop processing, really any of the processing, and it could be the start and stop commands as well. We can invoke a RexExec to do those things, one or more. The execs are processed in the auto operator address space, and the parameters accept variables, so we can pass variables to the execs. And then the return codes from the pre-start and the pre-stop execs can control the start and stop of the objects. So we can interrogate the return codes from those execs and then take action dependent upon what the results were. So Tom really provides more than just started tasks. For started tasks, they can be normal, as your typical started tasks, right? They come up, they go down, they stay up. They can be transient, so objects that come up, do some things, and then go away. Or they can be restart only, such as a lot of shops, for instance, will put LLA in their command member in sys1 parm line, but then they want to define it to Tom for shutdown, so they'll define it as a restart only object. We also support WLM resources as objects, so you can put your commands into your dependency flow, and it becomes a little bit easier to manage than having to write execs to do it around your automation. We support USS processes as well as stateless objects that support commands. Okay, so that's what I have for you today. I want to thank you all for taking the time to attend this session. I hope that you've learned some things. If you have questions, I encourage you to either send me an email at jcole@bmc.com, or if you like, you can type them into the chat window. We will be having these sessions once a month on various topics. We'll be posting them to communities, as well as the software consultants will send them out to select customers. If you're interested in getting invites to these in the future, just shoot me an email, let me know, and I'll be sure that we send you the invites in the future. Okay? Well, thank you very much for your time. I hope you all have a great day. Thank you.